Okay, in this recorded lesson, we're just going to be talking about factorising a specific type of quadratic. You guys have become quite good at factorising normal quadratic equations, where you sort of have to look at two numbers that multiply together to give one number and add together to give another. I want to talk about just one different special kind. But to start, what I'd like you to do is to expand each of these three different quadratic equations by multiple x by x and then x by minus 3, 3 by x and 3 by negative 3. I just want you to expand each of those, and you might have to pause the video because I sort of go on to the answers on the next page, but could you expand each of these separately and have a look at what you notice once you've expanded and collected the like terms. So just pause the video. Okay, so if we then look at the answers to these, so if this is the first one, what you'll hopefully notice is that if I do x by x, I get x squared, and then I get 3 by x, I get 3x, and then negative 3. You might have had these two the other way around, but ultimately you'll end up with the same answer. And what you'll notice here is that these two can be collected and actually cancel each other out because it ends up equaling 0, and we end up with this. Now, if we do the next one as well, same theory obviously, x by x, 1x, minus x, and minus 1, and again these cancel. So hopefully at this stage you're starting to notice that if these numbers are the same but they're only different by their whether they're positive or negative, they actually end up cancelling each other out. Now a shortcut on this can be that you just need to multiply the x's together and then the 1's together, and that's your final answer. So if we have a look at this, if I just put the x's together, I'll get x squared. If I do the 5's together, I'll get minus 25. I'll do it the long way here, just to prove again that these cancel each other out, and I end up with this. So, if we have a look at this one as well, this is the old way of doing it. So, this is what we're looking at before. Two numbers that multiply together to give 12 but add together to give 7, and in this case it's 3 and 4. So this is the old one. If you look at this one in comparison with the ones that you expanded before, you really just need to think about two numbers that multiply together to give 49, and in this case it's 7. So if I just make one of them positive and one of them negative, if I expand these out, they'll end up having two that cancel each other out, and our final answer will be that. Another way of thinking about it is x squared plus 0x minus 49. So 0x is actually the same as what's going on up the top here. It just doesn't exist, so we don't bother putting it in. And again, if you think about two numbers, the same theory, two numbers that multiply together to give minus 49, but add together to give 0, you're going to end up with a positive 7 and negative 7, which will give the same answer. So what I would like you to do is, can you please factorise these three by either of the two methods. You can either look at this number and just find it, or you can rewrite it with 0x in the middle, if that makes it easier for you, and factorise it. So I think you best pause the video and complete that, because on the next slide I'll work through the answers. And if we look at the answers, so the first one, 81, or minus 81, positive 9 and negative 9, if you multiply them together you'll get 81. The x's go together to give the x squared, and if we'd done it the long way and you'd multiplied the 9x and the x and the negative 9, they would end up cancelling each other out, and you'd get this as the final answer over here. So again, they're not too hard. You just sort of have to then look at this last number here and work out, you know, what could be two numbers that multiply together to give that. As long as they're the same number, then you're going to end up with the answers. So there's the final answers there, and that's it.